Well, hi, and welcome again to my shop, and we're going to start on this kind of crazy project I've got in mind, which is to take the 5 electronic kits like this one, this is my old one here, and build something out of all 5 of them that somehow connects together. This is my goal here. If you haven't, you should watch a couple of earlier videos on these, give you an idea of what I'm up to. So at this point, I'm going to start with this one. This is the Heathkit, the oldest one. The reason I'm starting with this one is one, I have the manual. 2, there's 3 transistors in here. And without studying anything very carefully, I get the impression this might be one of the better radios. So I want to start by building the radio. Well, there's a voice-operated relay, which I'm hoping to use too. 1, 2, 3 transistors in it. But I can only do 1 project per kit. I'm sure a voice-actuated relay is common. Will show up in one of the other kits too. Metronome. Where did the TV silencer? That's a good. Hey, where'd the radio go? I thought it was the very last one. I guess not, eh? Okay, let's just flip through till we find it. Because apparently there's a series of radio projects in here. Each one getting a little more complicated from the last. And voice transmitter. Here's a transmitter. 2 transistors. Yeah, I may have to change my plans here right away. Transmitter. Public address. 3 transistor radio. Well, this isn't what I remember. It must be another kit. 2 transistor radio with trapped. Oh no, this is it. This is the best and most powerful radio in this experimenter's kit. Combines all the best circuits of the other radios. 3 transistors. Fair bit of battery power. So I think this is the guy we want to build. Let's just read this here quickly. The coil and capacitor teamwork, just like the much steeper hill of experiments 3 and 5. And they have some crazy explanations in this book about how electronics works, and believe me, crazy is definitely the word for it. So I won't get into what they're talking about here with the hill. There's much better ways to visualize electricity. And you know, just on that score, visualizing electricity, if you really visualize, try your best to visualize what's really happening, you get into some trouble right away in your head. And I think, you know, everybody, I'm just going to talk for a minute about this. Everybody has the impression that electricity travels at the speed of light, and they kind of have this image of electrons shooting down wires at ridiculous breakneck speeds. The reality is very, very different. Any of you who have studied electrical engineering know what I'm going to say about how fast electrons move in wires. They barely move. They travel at a very low rate. It's, I can't remember the exact thing, but I think an amp is 1 coulomb of charge passing a given point in 1 second. And if you work all this out, it turns out electrons move about the pace of my finger here, down a wire. About like that. Not fast at all. So if you tried now to envision everything with this notion that the electricity is barely moving down the wire, you get into an awful lot of trouble. That's all I want to say is if you try to vision this stuff for what it really is, it's otherworldly. There's no doubt about it. What goes on with electrons and all that stuff is not the kind of thing we experience when we're in in our level of the universe, if you want to call it that. So I'm just now I have to show you one of these pictures. I think I showed this in the last video, but just how poorly done this one is. Let me find it here. And I'm not going to find it. Wouldn't you know it? an explanation of how a speaker works. The most horrible thing I've ever seen. And I'm not going to find it. Arrgh. Okay, we won't worry about it. I'll stumble across it at some point. Now, trying to keep on track here. The coil and capacitor team looks like a steep hill. Yeah, we're not going to do that. Reading the wrong one anyway. 2 transistor radio. 2 transistor radio with tapped coil. 3 transistor radio. The steeper hill does a much better job of separating stations that are close together. When the radio signal gets to transistor T1, it does 2 jobs just as it has been doing. The first job is to change the radio signal into an audio signal, one we can hear. Its second job is to make the signal much bigger. How about stronger? Transistor 2 makes the audio signal bigger again. Transistor 3 makes the signal from 2 even bigger. Since this radio will make the signals larger 3 different times, it will make even the real weak station strong enough for you to hear them in the earphone. Excuse me. Now, what are the chances that this is what's wired in here? There's something wired in here already. I'd say no. Okay, let's give this guy a try. I'm going to remove all the wires, I think. Oh, wait a minute. Wait a minute. Some of these fit the... Some of these wires seem to fit. Yeah, you know what? I think this is what's wired in here right now. Yeah, this is the radio. Well, it's getting a little easy, isn't it? There's a few things here that don't... oh no, that's right. This would be the radio. I think we got to put some batteries in here, or hook up a supply. Let's hook up a supply. Eventually we'll have to use batteries, but for now we'll use a supply. And this is a 4, so it's 6 volts there. 6 volts. That's about 6 there. Positive 1 would go to here. Let's turn off this power supply right now. And the negative 1 would go to number 41. This one here. You know what? I really think this is the... a few wires here that are loose. Number 41. Need to put an antenna on it. Oh man, this is too easy, isn't it? I really thought I'd be wiring this whole thing up. There's some fan stock connectors here. Well, now I'm going to listen in the headphone myself, first of all. We'll see what I hear. I'm pretty sure if I put this up against the microphone, you guys will hear it too, if there's anything there to hear. Okay. Let's take it out of my ear while I apply the power. There's the power. I'm listening. Oh. I hear static when I move this wire here. I think all these connections are bad. Oh yeah, all these connections are bad. Have a listen. See if you can hear any of this. I can't hear what you hear now, but hopefully you'll be hearing some scrabbly sounds in there. Let's see. And I'm waiting for it to jump to life here. Better. Dead silence up here. Funny capacitor, just why is that there? Okay, I think we're going to have to go through and check the whole diagram here, in case something's missing. So we still got to do some work. So we'll start right up here. From 1 to 11, right. From 11 to 14, right. From 13 to 19, 13 to 19, right. 15 to 12. Isn't this exciting stuff? 15. Hello, 15. 15 to 12. 12 to 2. Boy, if all checking all my radios was this easy. 12. 12. 12 to 2. 12. Yeah, 12 to 2. 12 to 20. 12 to 20. 20 to 23. 20 to 23. 23 to 26. 23 to 26. 26 to 58. 58 is the supply positive, which I have on. 60 to 65. Sorry to be doing this on camera, but 60 to 65. 60 to 65. I bring it down here. I guess it's to engage the switch down here. 64 to 59. Yeah, just puts this through the switch. 57. 57. 57 to 41, and this is the other supply. Here's 41, the other negative supply on it. That's correct. 40 to 21. Well, I wonder how long ago this was built. 40. 20. I mean, this could have been sitting like this for 30 years, for all I know. 40 to 21. 21 to 5. 21 to 5. 16 to 22. 16. 16 to 22. 16 to 22. 41 to 35. 41. 41 to 35. 34 to 24. 34 to 24. 43 to 25. 43 to 25. 37 to 47. 37 to 47. 46 to 36. 46 to 36. 36 to 27. There it goes, 36 to 27. 20 to 18. 20 to 18. 18 to 42. 17 to 6. 17 to 6. And 35 to 37. 35 to 37. So those are all the... find the extra 10 millifarad capacitor. Connect the end with the plus. Marks on it to 25. This is the capacitor. Ugh. Connect the other end to 24. Yeah, that's how it's in there. Connect the earphone antenna. So this looks like a bypass capacitor around the... well, I don't know about that. I'll take all that back. Now, these transistors may be shot. Who knows what's going on here? Stick it back. I should have had this in my ear the whole time I was doing that, by the way. Poking around like this. So I think this is one issue we're going to have right away is wire connectivity. I mean, this is the old set, right? So there could be all kinds of bad connections in here. The copper looks badly corroded. These copper springs. So, you know, I'm going to have to troubleshoot this thing just like any other. Any other radio. Finish the sentence, Jimmy. It's possible this thing is working, it's just so insensitive. Talking about insensitive, we'll go back to using my signal generator up here, which doesn't seem to be putting an output. But that's what we need to do. So, okay, so far we're off to a good start. Got the radio built. Not working yet. Maybe we should check the transistors here. I've never showed you my transistor tester, have I? I'm going to show you this to you. This has got to be the funniest piece of equipment going. I mean, it's a very, very serious piece of equipment. I got to show this to you. Okay? It's down here. It's not even up on my bench. It's down here. This guy. This guy here. Let's get a little more light on there. This big lug, Tektronix, you can see right up here. Transistor curve tracer. Look at this thing. Okay, the thing that killed me about this, that this guy has like Steve Axe in it. Okay, now by sorting out my problems, I really meant going and finding a piece of cable. The best I could do is this great big cable. But what I've done is I've just connected it directly from the output of my signal generator through the cable straight into the scope. It's a dual trace scope, so my other trace I brought up, here it is. And there it is. There's the signal. Just to verify, I'll kill the output. There it goes. There it comes back. So why is it not appearing on the other? What has gone wrong? Son of a gun. It's nothing worse than unreliable shop equipment. That's no good. Can't be doing well in a shop like this and keep wondering if your equipment's working. But then again, I'm doing this all with vintage equipment too, so it's going to have its problems. This should not be one of them. Now this is nothing more than a piece of wire here. Why in heaven's name won't it work? So go step by step, inch by inch. You know what one possibility is? My connecting system down here is may have a filter in it that's killing low frequencies. That's the truth of it. Let's take a look and see what happens if I bypass it here. Think hard now. Thinking hard. I gotta get a bunch of connectors. Here. There. So I'm going to feed the output of my signal generator from the end of this cable up here straight into my scope and verify that the signal's coming out. And how could it not be? I don't know. Don't know how it could not be. Now, how's this helping me here? Good thing to collect a whole bunch of little connectors and things like that. We're going to do this kind of work. Where'd that big cable go? I need it again. I think I'm going to be proving to myself I did something kind of dumb. I think that's what I'm about to prove here. Let's see. Wow. Surprising result. Expect this to show the signal here. And there's nothing there. Except some funny junk. How come? Okay, so I'm just going to check continuity from one end of this cable to the other. No excess cable here, that's for sure. That's what I'm looking for on my somewhat unreliable meter. Holy smokes, how am I going to do this? Clip leads, clip leads, clip leads. First we'll check the center conductor of this cable. How in heaven's name it could be broken, I have no idea. No idea. Here's the other end. I just feel terrible here. Okay. That's the outside. And now, what about a short circuit right in this cable? I have the feeling if there was a short circuit, my counter wouldn't read anything. Okay, so cable's good. There's just no reason. There's no reason. There's no reason. Daddy, why is the sky blue? Son, there's no reason. this. No. I sure don't get it here. I'm gonna have a heart attack if this doesn't work. Well, I guess a heart attack's not quite appropriate. I'm gonna throw up if this doesn't work here. No, wait a minute, now that wouldn't be appropriate either, would it? Really? I'm gonna have a conniption. There we go, I'll say I'm gonna have a conniption if this doesn't work. Because nobody knows what a conniption is anyway. Oh, for crying out loud. I can't believe it. Okay, let's bypass the good cable. This is just driving me nuts. If there's one thing I really have little patience for, it's going backwards. Yeah, I don't mind standing still when you're investigating stuff, but the going backwards part really bothers me. Problem is right in the connector here. What's going on? Okay. There's a big strong signal coming out of there. Yep. It's making it all the way to the scope. There, take a look. It's up here, like this. Get rid of that line. There it is. Just to prove it, I will turn down the generator output. See? There it is. Lots of signal there. Now, if I just insert this white piece of cable. That's supposed to be a radio repair shop, not a wire troubleshooting shop, for crying out loud. What about this thing? Could this be a bunch of malarkey? I don't think so. And that signal should reappear. And my gosh, there it is. This is even more reason to have a conniption. I'm having a conniption off camera where you can't see it. Okay, let's just one step at a time here.
You see, what I've done, I haven't been explaining this, is I've used a bunch of TV splitters to assist me with all these connections to test equipment, radios and test. And a lot of these TV splitters, this kind of thing, a lot of these TV splitters have filters in them. And they make the filtering out lower frequencies. They may be doing that almost by accident. Now, I should see it now, because all I've done, basically, is insert the splitter. So, now these splitters are qualities. Some of them are really crummy. The odd one, if you open it, there's nothing in it but a wire. Okay, so it looks like my pair is the splitter attenuating the low frequency radio signal coming from a generator. And it's not moving it through at all. So I'm going to connect to a different splitter. No, never mind this. Now we're into experimenting with splitters, for crying out loud. And there's this thing coming through. It's attenuated a bit, but it's coming through. Okay. Let's just see what happens now. If I here and put that there, should have signal going into the radio here. So you make the antenna. Okay, looks like we got a signal. There we are. Look, there's definitely a signal going in the front end of the radio. Well, let's see what's coming out of the rear end of the radio. Doesn't that sound like an attractive thing to do? So I have the headphone in now. Power's on and connected. Volume's up. I hear nothing at all. Nothing at all. Nothing. Yeah. Silent here. Let's get the schematic up in front of us here. Transistor number 21. So that's the first one here. Doesn't seem to have any left. I'm getting pretty silent here now, aren't I? It's been a pretty crummy video, frankly. But, as I say in my channel description, you see what happens. So, in this case, you see what doesn't happen. I don't know what I think here. It's a very simple circuit, but the transistor that should be the detector just appears to have no effect on anything. The audio system seems to be working. Here, listen. Assuming you can hear it again. So that's the base of the second transistor. The first transistor doesn't seem to have any effect. So I'm not sure if you're hearing that. I'm just holding the earpiece up to the camera mic. Isn't it? Well, we're off to a really bad start with our plan here. I don't really want to give up on this one right away. The transistor tested good. Or at least all three of them tested the same way. Oh, here's something interesting. Here's something a little interesting. Look at that burn mark through here. That's clearly a hookup wire. Clearly it's been burned. So maybe the continuity of this coil shot. Let's check. Oh my god, I'm troubleshooting this like any radio. So we'll disconnect the wires here. Just two of them's enough. Get out this trusty ohm meter. Not so trusty. Okay, so there's continuity through there. Continuity through there. Well, there's continuity in every direction, so I don't think there's anything wrong with coil. Okay. That little thrill on. Must have been exciting when whoever hooked something up and hit the switch and smoke from that coil. It must have jumped. I would expect it. Hook it back up. Power back on. Okay, so what if this is tuned way out of band? Don't seem to hear anything. Okay, let's signal trace. Okay, that's the antenna. Should see exactly the same thing there. And here. And was here.
Okay, let's give it another go. Just took a little bit of a break here. You know what I should do? I should put these onto a speaker. Wouldn't that be a smart idea? That would be a smart idea. Okay, let's do the smart idea thing here. And how do you do that? Okay, so yeah. Should have thought of that earlier. Hello. Where's my... Yeah, okay. Bear with me for a couple of minutes here. While I know what I'll use. I'll use this. I'll use my signal tracer. This to the output, and this guy here, stay up there. There we go. Oh, doesn't that work? Okay, so we got a screaming noise coming out of there. Apparently has nothing to do with anything here. Oh. Well. Let's hope nothing bad happens. Somewhere there I knocked the power supply from its proper 6 volts to 15 volts. Oh man. Okay. There we go. Now you can hear the troubleshooting process here. Sorry I'm being so quiet while I do this. Yeah, this not working this way. Let me get this. I have the feeling that these TV splitters were a bad choice, and I was suspicious right from the start that they may have filters in them that are going to mess up what I'm trying to do with them. But they sure are convenient. Okay, now we are connected straight to the output of this guy up here. This guy here. The output of this, which is red there. Now, I'm imagining the tuning on this little radio is terrible, so if I get anywhere near it, we should hear. Well, it's working a little more like a radio. So that's the audio amp working fine. The audio signal should be coming from here. And that's simply the output of the coil and the capacitor in parallel here. which we don't seem to be getting any output, any radio action. So I keep pointing to the idea that this transistor is not working. Coming and going. Okay, so what is it? It appears to actually be the what happened? Oh, the antenna came right off. Come on now. A lot of weird connection problems here. Get some business going. I've still got my oscilloscope connected here, so I'm looking over at my oscilloscope where it's connected here, and I keep glancing at it. When you hear the signal, I see it here. The signal here is simply straight from my signal generator. It's not going through any parts here. So why is the signal coming and going when it certainly shouldn't be? What the heck? Somebody please explain to me what is going on here. Not much of a tuner here. that signal just seems to work its way through there. I have no idea why it's behaving the way it's behaving. All I'm doing is just changing the frequency of the signal generator a little bit. I would say there's no resonance in the tuning circuit. Where'd it go? Well, needless to say, this would be tricky. Why did it go away? The signal's gone away right from the signal generator again. Come on back. Come on back. I'm telling you, this is the most. There's the signal. What is going on that it wasn't there a moment ago? Okay, the signal's there now. The signal has gone rather weird. What's just happened? Increasing frustration is setting in. No signal. Where'd it go? I'm really finding this it's getting to be downright upsetting at this point here. I can't get off the ground floor with this signal generator problem. Oh my God. I thought I had that sorted out. Okay, I'm getting a little bit of information here. The radio circuit is shorting out. The input. Signal. Now let's think, what kind of tuner is this? This is it's a capacitor and coil in parallel. When they resonate, they present a high impedance to the signal at that frequency. In all other frequencies, it looks like a short circuit. So, unless I have the correct frequency dialed in on this, we should see no output. It should appear to be a short. That seems to be what's happening. Man, we were cooking there for a bit. I wonder if that was all false operation in some way. I haven't turned up high enough. It's up pretty loud now. Another possibility is this capacitor is way off. I'm sorry, this one here, way off. And so maybe the coil's off. I don't know how. I could set the resonant frequency way out of band. Who knows? I don't know. All I know is I'm going from bad to worse here. We had it going there for a minute. Well, I'm unconvinced I'm getting a signal into this to begin with. Still unconvinced. Because my scope is telling me there's no signal. But we gotta start right back at square one again. Take all this off. And there's the signal. Okay, so there's definitely a signal here. Keep the ground off, we seem to get a little better. I should probably measure that capacitor and see if it really is a 180 picofarads. boy, if you could see the look on my face at this point in this affair. This is just a terrible situation here. I'm having zero luck on anything. Now this is kind of interesting now. If the circuit here, the tuned circuit, the capacitor and the coil, present a low impedance to all frequencies other than the tuned frequency, that might explain why my signal generator does not put out enough power to operate my counter anymore. See how it's flicking there? I just disconnect the signal generator from the radio here. See how it just went stable, the numbers? So when I put this on, it causes that effect. No sense of radio operation there at all. And tell me I've got a bad cable in my test system with an intermittent on it or something crazy like that. Let's see. Something's not right. Let's get a different cable here. The frustration is building in me. I can feel the need for a break coming. I'm gonna throw something pretty soon. Okay, let's try a different signal lead here. I can't imagine this would make any difference. Then again, oh my god, all this time it's been a bad wire. What the heck would be wrong with this? I'm red-faced. But hold on, before we jump to too many conclusions. Testing this cable now. What happened? Where'd all that noise go? What, oh my. Sounding like a real radio here. The thing is, I disconnected the circuit. It's no longer connected properly, and it seems to work better. Jeepers. Okay, let's connect this up and see what happens here. Ground has come off. Oh, I never got the ground on. What happened? Just a myriad of bad connections in here, and perhaps that's all this is. It's just one bad connection after another. Well, I'm going to disconnect this wire again here. Everybody hold your ears. Hold your ears. Look at that. Okay, it's receiving, but there's really no tuning to it. But it's definitely receiving. We're cooking here. Okay, now, why when I connect this circuit properly does it just go dead? Because I've never tuned it far enough. Let's find out if that's the problem. I hear something. It's very faint. Oh my lord. Jeez. Well, maybe we're going to abandon this one as the radio receiver. I'm not going to get anywhere with it at this point, I think. So let's do that. We'll abandon using this as the radio receiver. We'll try using the radio. There's a transmitter in this kit. Maybe we'll try that later. We'll find another kit, try another receiver, see where we can get. Because I'm getting nowhere with this. And I'm afraid my level of frustration's a little high here. So let's, think about it for a minute. I'm doing this with all this test equipment around here and I'm not getting anywhere. Imagine trying to do this without any test equipment and you hook it up and it doesn't work. And this might be something about using these old guys. Contact problems, maybe I just haven't found the particular contact problem yet. Not very likely, but maybe that's the case. Maybe this transistor is shot. I don't know. who knows? I mean, I showed you the burn mark over here. I don't know. I think we're going to try a different one. So, if you've watched this whole video very patiently, hoping to see me get this working, I apologize, but that's the reality of the situation here. And maybe we'll have better luck with another one. So, see you on the next video.